Hello everyone, welcome back to another one of my videos. Thank you for clicking on this video and watching it like I told you guys to in class. I promise you it's going to be very helpful. Since I wasn't able to do any of these problems with you guys in class, I just want to make sure everyone is understanding. Of course, we're going to do more when we get back into class later this week. But for now, while you're home, you could watch this video to help you start it, and hopefully it'll help you understand. So we're going to start with the first section up here. Okay, I'll do like one from this section, and I want to do 3 from here, and then we'll do 3 from here. Okay, so I want to make the video as short as possible, so let's get started. First section is very simple. Everyone should know how to do this already. You want to draw the Lewis dot structures for each element that you see here. Okay, my problems are different than yours, so remember there's an error here for mine, so I changed this element. I added charges to some of them. So your elements are different, but it's the same thing, right? You're just drawing the Lewis dot structure for each element. So, for example, argon. Argon on the periodic table is located in the noble gas group. I drew a mini periodic table here for us. Okay, it's located in the noble gas group right here, meaning it has 8 valence electrons. So because of that, I will draw 8 dots around argon, putting 1 on each side before doubling up because of Hund's rule. And that gives us 8 valence electrons for argon, and that is the finished product. Super easy. Okay? Let's try another one. This one has a charge, so I just want to do a quick one with a negative charge. And obviously, if it has a positive charge, you do the opposite. So when an element has a negative charge on it, we call this an anion. You guys should have learned this. We did this already for the ionic bonding quiz. Ionic compound naming quiz. We already talked about anions and cations. Everyone should be experts at this. So when you have a negative charge, right, that is an anion. Anions gain electrons. This means that oxygen, even though he does, according to our periodic table, have 8 valence electrons, he's actually gaining here because he has a negative charge. So he has 6 valence electrons off the periodic table. There's a 2 negative charge, meaning he's gaining 2 electrons. So it's 8 electrons now he has. So I'm going to redraw him with 1, 2, 3, 4, 5, 6, 7, 8 valence electrons with the charge because I have to put the charge to show that it's an ion. If not, it will be wrong because then you're telling me that neutral oxygen has 8 valence, and that is not true. So oxygen as an ion has 8 valence. That is true. Okay, and you would do the same thing for the positive charges, but remember the positive charges, they are called cations. So they lose. They lose electrons. Okay, they lose electrons. So it's going to be the opposite. You're not adding, you will be subtracting whatever the charge says. Okay? And that's how you do section 1. Let me make sure it's recording because it wasn't before. Okay, phew, good. Perfect. Moving on. We are going to do these 3 questions together. We did really basic ones in class. These ones are a little more complicated because they have multiple elements. So we are going to do these together. Okay? So starting off with number 16. I like 16. 16 is a good one. Starting off with number 16. In class, we came up with the step checklist, right? So we wrote out our steps, and we went one by one to solve every single problem. These are very easy as long as you go through the steps and you do everything you need to do, and you have a periodic table handy. All right, so we're going to start off with step 1. Step 1 is identify the central atom. Okay, how do you know what is the central atom? So you look at your periodic table. I drew one over here, and you're trying to find the element that has the distance farthest away from fluorine. Okay, so I have 3 elements here: carbon, hydrogen, oxygen. Here's fluorine right there. I want the element farthest away from fluorine, but of course everyone knows hydrogen can never be the central atom, so I'm going to cancel that one out. So it's between C and O. And obviously if you take a look, here's C, here's O. C is the farthest away from fluorine, therefore C will be our central atom. Okay, so I'm going to put that together. C. Next, the formula is really going to help us place these atoms on this compound, on this Lewis dot structure. Okay, so step 2 on our list is place remaining elements from formula around central atom. Okay, let's take a look. So we already know that we have 3 hydrogens, 1 oxygen, and 1 hydrogen that needs to be attached to our carbon. But remember, carbon can only have 4 bonds because it's, a normal element. There are only 5 elements that you know of that can take more than 4 bonds, and that's silicon, phosphorus, sulfur, xenon, and krypton. Okay, and that's none of this right now. So carbon can only handle 4 bonds, so I can only draw 4 things attached. But I have 3 things, 4 and 5 things. So how am I going to attach that 5th thing? I'll show you. Okay, so let me erase all this. Again, we're starting off with carbon as our central atom. The formula is going to help us piece it together. So the first part of the formula where carbon is, I have 3 H's that are directly touching this C. Meaning, if these 3 H's in the formula are directly touching the C, those 3 H's in the Lewis dot structure will be directly touching the C. Okay, so I'm going to draw those 3 hydrogens touching the carbon. I'm going to move this. So 1, 2, 3 hydrogens. Okay, so this is CH3. We just drew half of the molecule. CH3. 3 H's attached to my central atom. Okay, next, my oxygen is also going to be attached to my central atom. Okay, so since it's, very close to my carbon in the formula, it's going to be attached to the carbon. Okay, OH should look familiar to all of you. OH is hydroxide. Okay, not really hydroxide right now, actually, because it's not charged. So I shouldn't say that, but it looks familiar. It's OH is hydroxide. So this should be connected together. So my last hydrogen will actually be connected to the O. Does that make sense? So the formula will always be able to help you most of the time in placing the atoms. Okay, remember, I cannot have more than 4 bonds on carbon, so I was not able to put this hydrogen also attached. It just would not make any sense. OH is a compound. Again, all of you are familiar with OH is hydroxide. Here's hydroxide. And this is the basic structural formula of my compound so far. Okay, so that's step 2. We placed remaining elements from the formula around our central atom. Step 3. Add up all valence electrons from all atoms in the molecule. Okay, so let's go back over here. Carbon has how many valence? 4. Oxygen has how many valence? 6. Hydrogen has how many valence? 1. But I have 1, 2, 3, 4 hydrogens. So how many total valence? 4 valence. Okay, all of these numbers I get from the periodic table. So 1 valence for hydrogen, 4 valence for carbon, 6 for oxygen. That's how I get the numbers from. Okay, perfect. So now what do I have to do? I have to add these numbers up together. So 4 plus 6 is 10, plus 4 is 14. So I have 14 electrons. Okay, that's step 3. Next, step 4. We are going to subtract the electrons. Oh my gosh, this always happens. Subtract the electrons. Hello? Subtract the electrons that are all, oh my gosh, ready being used in the molecule with bonds, which, are lines, the same thing. So again, step 4 is subtract the electrons that are already being used in the molecule with bonds. Okay, so subtract all the bonds, basically what I'm trying to say. So this bond this is a bond, this is a bond, this is a bond, this is a bond. We have five bonds here, 5 lines. Everyone knows that one line is equal to 2 electrons, okay? One line, again, is equal to 2 electrons. So, if I have 5 lines here, how many electrons will I have to subtract? 10. Perfect. Okay, so, erasing this. 2, 4, 6, 8, 10, and I will subtract 10, and I'm left over with 4. Okay? Step 5. Place remaining, I keep doing that. Remaining electrons, what should I say? Place remaining electrons, oh my god, on outside atoms first. If you still have any left over, place on central atom or any, oh my god, I can't write, any other element nearby. Oh, jeez, I cannot write and I hate this iPad. Sorry, guys. Perfect. So, going back, we have 4 left over, and this will be my valence electrons. So, the step says, place remaining on outside atoms first. So, my outside atoms, here's the central, okay? Outside atoms. I could even count oxygen as an outside atom, but let's not say that, because right now he's not really outside. He's in the middle. You see that? He's not outside. The hydrogens are all on the outside. And what did we already learn about outside atoms? These outside atoms will take my lone pairs first, except hydrogen. He cannot take any more electrons because hydrogen is located in the first period, right? This is first period. So that means he only has 1 energy level around him. And since he has 1 energy level around him, it can only hold 2 electrons max. Therefore, if he already has a line attached to him, he already has his maximum of 2 electrons. You can't add any more electrons to hydrogen. Therefore, these 4 cannot go to any of my hydrogens. So then that means we have to place the remaining on the central atom, okay, to make it happy. So my central atom we said was carbon, but look at that. Carbon already has 1, 2, 3, 4 bonds, meaning it already has 2, 4, 6, 8 electrons, meaning it's already happy. Okay, it's already octet. Hydrogen is also happy. Every single element is happy. Except for maybe oxygen. Let's see how many he has. So here's oxygen. He only has 2 lines attached to him. Line over here, line over here. So that means he has 2, 4. Oxygen only has 4 electrons on him right now. Therefore, he's not happy. He wants to have 8. He wants to achieve octet. That is their whole goal. Lucky for him, we have 4 leftover electrons that maybe he could take, right? So these 4 will actually go to oxygen to make oxygen happy. Because the goal of putting these is to make everyone happy and to make everyone achieve octet. Okay, so when I place those electrons, I have 4, right? So I put 1, 2, 3, 4. Remember, these are lone pairs. So you must place them as pairs. Jeez. Wow, this iPad, I literally hate it. I hate this iPad. If anyone wants a free iPad, you can take it because I hate this iPad. Sorry, it makes me so mad. But anyways, these 4 again get placed on oxygen as pairs. So 1, 2, 3, 4. And there we go. Now everybody is happy, and that is my final molecule right here. So this is what it's going to look like. Okay, that one was a little tricky with the whole, oh, we don't really have a central atom. We have 2 central atoms, but we figured it out, okay? Let's do another one. We are going to do number 19. Okay, so number 19. I have H3CN. Okay, there's another thing that you should be familiar with over here. Maybe similar to OH, right? OH is a polyatomic. CN is polyatomic. Keep that in mind. Okay, step 1 says to identify the central atom. So I'm going to come over here and I have, again, three different elements, H, C, and N. And I need to find out who the central one is. I can do that by looking at the periodic table and seeing who is farthest from fluorine. Obviously, hydrogen is never the central atom, so it's between C and N. Obviously, carbon is farthest away from fluorine, therefore carbon will be the central atom. So I will draw carbon in the middle. However, I have two carbons attached, so both of them will be my central atom, and they are connected to each other, right? So all of these things are connected. Perfect. So I have my two central atoms, the two carbons. They're both in the middle. Okay, again, look at the formula to help you. So here's that carbon, here's the other carbon. Well, this carbon has who attached to him? 3 hydrogens. Perfect. So I'm going to take those 3 hydrogens and put it on that carbon. So I'm gonna put this one in pink. Okay, so it makes it more simple. I'll put that one in pink, and I'll put this one in like purple or something. Okay, so here is my purple carbon. And then I'll draw the bonds in black for now. Perfect, okay? So here's my pink carbon, here's my purple carbon. Again, this carbon, who is attached to him directly? The 3 hydrogens. And we already attached the other carbon next to that guy. So on the left side of him, we're putting 3 hydrogens. So I'm going to put 1, 2, 3 hydrogens. Okay, again, use the formula to help you write it out. There's my CH3. Okay, next, I have a nitrogen. So this nitrogen is directly attached to my purple carbon right here. So I will draw my nitrogen attached to the purple carbon. Perfect. And there is my molecule. Okay, kind of similar to the other one. Everyone hopefully sees how I drew this. If not, if you have any questions, you can always ask me, and I can try to re-explain. Okay, beautiful. So now, what are we going to do? We need to do step 2. Oh, wait. Well, this is already step 2. I'm kind of ahead. We already did step 2. Step 2 was to place remaining elements around central atom. We already did that. Okay, next, step 3. Add up all valence electrons from all atoms in the molecule. Okay, so let's start off. We have 2 carbons. Okay, so those 2 carbons have 4 each, giving me a total of 8. I have 3 hydrogens. Okay, 3 hydrogens, 1 each, giving me a total of 3, and 1 nitrogen, giving me a total of 5. And when I add these all up together, I get 8 plus 3, 9, 10, 11, plus 5, 16. There we go, 16. Beautiful. So we added up all of our electrons that were already in the formula. Okay, next, we need to subtract the electrons that are being used as bonds in the molecule, the lines that we drew. So how many lines did we draw? We drew 1, 2, 3, 4, 5 lines. Each line is 2 electrons. So how many electrons do I have? 2, 4, 6, 8, 10. So I will be subtracting 10 electrons. Beautiful. Now I have 6 left over. These 6, take a look please. These 6 will be our remaining electrons, and we have to put them on our outside atoms first. Okay? If you have any left over, put it on the central or anyone around him. Perfect. Easy. Here are my 6. Who are my outside atoms? These guys, right? So outside, outside. He is not outside. He is surrounded here and here. So he's not outside, okay? Here are my outside atoms. I have 3 hydrogens. 1, 2, 3, and a nitrogen. Those are my outsides. We already established that hydrogen can never receive any extra electrons, so we're taking him out. This nitrogen, on the other hand, needs some more electrons to be happy, to be stable, to be octet. Okay? Right now, this nitrogen has how many electrons? 2. This line is attached to the nitrogen, meaning he has only 2 electrons. So how many more does he need to be happy? Well, he needs 8 total. He already has 2, meaning he needs 6. Perfect. How convenient that we have 6 left over. So we're going to take this 6, okay, and place them on the nitrogen as lone pairs. Okay, so I have 2, 4, 6. Excellent. Now my nitrogen is happy because he has achieved octet. Beautiful. And we already know that all my hydrogens are happy as well because they have their own version of octet. They all have 2, and that makes them happy. And then the carbon in the middle, he has 1, 2, 3, 4 bonds, making him have 2, 4, 6, 8 electrons, making him happy. So everyone here is happy. Wait, hold on. Actually, not everyone here is happy. I don't have a smiley face on C. So let's see. Well, C has 1, 2. How many does he have right now? He has 1 and 2, right? 2 bonds. Each bond is 2 electrons. So he has how many left? 2 and 4. He has 4, but he's not happy. Where are the other 4 that he needs to be happy? We already used up our 6 on nitrogen. We have no more electrons left to give him. Okay? So this is where double and triple bonds will be formed. Okay? So if I can make a step 6. If one of your atoms are not happy, meaning they don't have octet, form double or triple bonds to fix it. Okay, perfect. So here's what I'm going to do. In order for us to form double or triple bonds, you need a lone pair. Okay, we do have lone pairs, so we can do this. Perfect. I can't just like randomly just draw lines wherever I want, making people happy. No, I can't do that. I don't have those electrons to do that with. So I would have to, trade in a pair to become a line, for example. Now, luckily, carbon, this guy who's unhappy, he only has 4 electrons right now. He needs 4 more to have an octet. He needs 4 more. And then once he gets to 4 more, he'll be 8 octet and he'll be happy. Okay? These 4 that he's going to get will be obviously from a double or triple bond. Okay? So in order for us to form double or triple bonds, we need to have a lone pair. Which, lucky for us, we have 3 lone pairs. So what's going to happen is nitrogen is going to be super nice, and he's going to allow carbon to take, hold of his lone pair and form a bond. So we are going to erase these electrons right here, and we are going to form a bond with carbon, a double bond. Okay, so right now, carbon has 1, 2, 3 bonds, making him have 2, 4, 6 electrons. He still isn't happy. He needs 2 more. So what we're going to do now is we're going to form another bond. So we're going to take another pair of nitrogen's electrons, erase them, and we're going to give them to carbon to share. So now, carbon has 2, 4, 6, 8 electrons, making him very, very happy. He is octet, and nitrogen still has 2, 4, 6, 8 electrons, making him happy. So now every single atom in my molecule is happy. Remember, nitrogen likes really to form triple bonds, so this works out for him, okay? And that is how you do number 19. Hopefully that made sense. Okay, last but not least, number 15. Do I want to do number 15? No, I don't. I feel like you guys could probably do number 15. So that's you. Okay, I want to look at the back page. Okay, so let's take a look over here. Each of these molecules are the molecules from over here. Okay, once you draw out all of the Lewis dot structures for all of these molecules, okay, once you do all of that, you're going to do the back page. So far I've drawn 2 molecules for 16 and 19. So I'm going to do these 2, okay? So it's going over here. Take a look. This compound right here is CH3OH. So I'm going to come over here to the back and find CH3OH right here. Okay, so we're doing this one. It wants us to count the number of single covalent bonds in the molecule. So again, go back to this problem on the other side of the page, CH3OH. Go back over here. CH3OH, and count how many single bonds do you see. Okay, I see 1, 2, 3, 4, 5 bonds. 5 single bonds. So I'm going to come back over here and I'm going to write that I have 5 bonds. This part asks for the number of lone pairs, heavy on the word pairs, on oxygen in the same molecule. So going back to that number, that problem, we're going to go over here. Okay, going back. How many lone pairs do I have on oxygen? Well, how many pairs do I have? 1, 2. I have 2 pairs, right? 1 pair means 2. So I have 2 pairs on oxygen. And I put 2 over here. Okay, doing the other guy. Next, right here. This is H3CCN. So let's go find H3CCN. right over here, okay? So now we're doing this one, H3CCN. Now, it wants us to count the number of single covalent bonds in the molecule, as well as triple and lone pairs. So let's go back to our molecule, okay? We're trying to find single covalent. How many single covalents do we have in the molecule? Right here. I can count 1, 2, 3, 4 singles. That's a single, right? These are singles. So I just have 4 single covalent bonds in this molecule. I will write that I have 4 single covalent bonds. This is a single. This is a double. And this is a triple. Okay? This question says, how many triple bonds do we have? Let's go back over here. Again, to our problem. How many triple bonds do we have? I see only 1 triple bond. Okay, this is 1 triple bond. So I'm going to put 1 over here. Then it says how many lone pairs we have on nitrogen. So go back to the same molecule. Here's nitrogen. How many lone pairs does he have? He has 1 pair. So nitrogen has only 1 pair. Okay, and there is our final answers for those. So you do the same thing for the other ones, right? Look at the molecule from the previous page and count up what it's asking you to count up. And that is how you do this worksheet. Hopefully this was very helpful for you. If you have any questions, please ask, and have a good weekend. Have a good night.